All right, today is the last lesson of Unit 1. Yay! We've reached the end of something. This is really exciting. We're going to talk a little bit about properties of real numbers because I think understanding what some of the vocabulary means, it will help us when we get further into like solving equations and algebra and stuff. Okay, so first off, get your note sheet out and make sure you fill in what I have filled in here. All right, the commutative property. Okay, so the main idea is order does not matter with addition and multiplication. Okay, commutative property. So if we look at some examples, I have addition examples. A plus B is the same as B plus A. I can switch the order and I'm still going to get the same answer. The same is true for multiplication. A times B is the same as B times A. My next example is just using numbers, right? 7 plus 5 is the same as 5 plus 7. We just switch the orders, we still get the same value. I'm not asking you to solve this or simplify it. I'm just trying to give you visual examples of the property, of the commutative property, sorry. Here I have AB times 7 is the same as 7 times AB. I've just switched the order, and that's okay. 3x plus 8 is the same as 8 plus 3x, right? We just switch the order, and we still get the same result. Over here with multiplication, I have negative 5y times 4 is equal to 4 times negative 5y. As long as we have the same terms, right? I have negative 5y, 4 and 4. When you're multiplying or adding, you can switch the order and that's okay. All right, here's another example. For addition, y plus 9x is equal to 9x plus y. That is just the same as the one above, only now I have two variables here, but I'm simply just adding two terms together, and if I switch the order, that's okay. Multiplication, the reason I use parentheses here is just to keep the order of operations preserved, okay? X plus y, whatever that is, all of that times 3 is the same as 3 times whatever x plus y is. Okay, because if I didn't use parentheses, it would look like 3 times y happens first here on this side, and on the other side, it would look like 3 times x. So I use parentheses to preserve the order of operations. So those are just some visual examples of commutative property. If you need more time, pause the video. Okay, so now with the associative property, grouping doesn't matter with addition and multiplication. So what I want to say about this, and maybe you will see what I'm saying, and I'm not trying to be inappropriate, but if you see associative, right, associative property, oops, I don't have my pen on, will always have parentheses in it. And parentheses kind of look like a but. So associative, right, we're going to have parentheses, and we're going to group those parentheses with different terms in addition and multiplication. You will see what I'm talking about in just a second here. All right, so associative always has parentheses. Not to be confused with the commutative property with the one above that I use parentheses. So here are some examples. So if I associate, oh, I keep doing that, I'm so sorry. If I associate with 8 and 9 and then I add 7, that is the same if I add 8 to associating with 9 and 7. Do you see how the parentheses, the order of the numbers in each side of the equation or example are in the same position, right? 8's the first number, 9's the second number, 7 is the third number. They're all in the same order, I've just moved the parentheses over one. Here in multiplication, again, they're in the same order, A, B, C, A, B, C. In the first half, or the left side of the equation, I associated with BC. So A times all of BC is the same as AB times, or all of AB, A times B, times C. We just move the parenthesis. Here we go again. What you're looking is preservation of order. I just want to quickly go back and show you that in this example for multiplication of commutative xy3, then it's 3xy. They're not in the same order. That is not associative. All right, we're just grouping. We keep the values in the same order and we just change where we group our parentheses. So make sure you copy these down so you have good examples. Here in my third example for addition, 7a plus 2 plus y is equal to 7a plus 2 plus y. 7a, 2y, they're all in the same order. Over here, multiplication, 6x times the quantity 2y plus 3 is equal to 6x times 2y, all of that, times 3. See how they're in the same order? 6, 2, 3, 6, 2, 3. All right, last example, 6 plus the quantity 3a plus 1 is equal to 6 plus 3a, all of that, plus 1. We just moved the parentheses from here. Oh, I do it again. Right, so we started with the parentheses here, and then on the left side, they're here. Okay, I just moved them over. But the order of the terms is all the same. All right, last example for multiplication for associative, 4a times the association of 3b times 5c is equal to 4a times 3b, all of that, times 5c. All right, this is like, we're not solving anything, so I don't want you guys like freaking out. We are just trying to define these properties. So we know commutative, the order doesn't matter. We can switch it up. But in associative, the order does matter, but we associate with different terms on either side. And associative properties always have parentheses. Associative looks like a but. All right, the identity property, keep the value of the number. The identity, you want to keep yourself, right? You are you, so keep it that way. Here's some examples, right? What number can we add to any number that's going to keep the number the same? My favorite, 0. Okay, so we can add 0 and still keep our number. We start at 9, we add nothing, we're still 9. But for multiplication, the number that we use to preserve our identity is 1, because anything times 1 is going to be itself. 7 times 1 is 7. So we add 0 to keep identity, and we multiply 1 for multiplication. All right, 4a plus 0 is 4a. 6x times 1 is 6x. Last one, negative 7g plus 0 is negative 7g. Negative 3b times 1 is negative 3b. So we want to keep the value of the number. So if you are using the identity property, you will add 0 for addition, and you will multiply 1 for multiplication. All right, inverse property uses the opposite to cancel out, okay? So you want to think about what's the opposite. So in my examples for addition, 10 plus negative 10 is 0. They cancel each other out and I get nothing. So when I'm using the inverse property with addition, I'm always going to end up with 0. When I use the inverse property with multiplication, I'm always going to end up with 1. The inverse, when we multiply, of 10 is 1 over 10. So 1/2 plus negative 1/2 equals 0. All right, that's good. In my multiplication example, I have negative 1/3. The inverse of that is still negative. It's just flipped upside down. So now it's negative 3. Negative 1/3 times negative 3 is positive 1. You can also check that out in your calculator. I mean, that's pretty fancy, pretty fancy. All right, negative 7 plus 7, they are inverses of each other, equals 0, right? They're opposites when it comes to addition. Opposites when it comes to multiplication are kind of like reciprocals. right? Remember, a reciprocal is like you flip it upside down. So b and 1 over b equals 1 when I multiply those together. All right, last example. X plus negative x is equal to 0. I only use the parentheses here with the negatives kind of just to contain the negative because I'm adding the opposite, and I just wanted to express that. I didn't want to make this x minus x. That would not be an addition example. That would be weird. All right, multiplication, 5 over 4 times, flip it upside down, 4 over 5, we get 1. That is the inverse property. We try to cancel out. Multiplication always equals 1. Addition always equals 0. All right, next property we're going to talk about is the property of 0, not to be confused with this one. This property of 0 is only anything multiplied by 0 equals 0. That's like a fact, okay? We're multiplying strictly, where in the last one, it was equaling 0. We weren't multiplying 0 or adding 0 or doing anything like that. We said it was going to equal 0 when we add the inverses. So property of 0, anything multiplied by 0 equals 0. Here's an example. 5x times 0 is 0. The quantity x plus 7y times 0 is 0. We have to use parentheses here because if you didn't, it would look like 7y times 0 plus x, and that would equal x. So property of 0 always equals 0. All right, last one we're going to talk about the distributive property. We multiply a value to an expression in parentheses. We used to call this the rainbow at my old school. We're going to do the rainbow. All right, this is for multiplication. When we distribute, 5 times x gives me 5x. 5 times negative 2 gives me negative 10. Kabushki. We distribute to both terms inside the parentheses. A times b gives me AB. A times C gives me AC. It's very important that the symbol or the sign stays the same in between the two terms. Unless, of course, we're distributing a negative, then things might change just a scooch, as we will see in my next example here. All right. Negative 1/2 times 20, well, half of 20 is 10. Half of negative 4 is negative 2. So when I distribute a half to 20x minus 4, I get 10x minus 2. In this example, I am distributing a negative. So I'm going to get rid of this for a second here. All right, when I distribute that negative, the signs are going to change, right? Negative 7 times positive x gives me negative 7x. Negative 7 times negative y gives me positive 7y. So we would put a plus sign in between because the 7y was positive. All right, so now we're just going to look at the 8 examples at the bottom of this paper called Name That Property. Okay. Name that property. First off, I see parentheses. I'm like, oh, I'm thinking associative property. I need to make sure that the terms are in the same order on left side and right. 4AB, 4AB. Whew, I was right with my initial reaction. It is associative property of addition. Right? This is all addition here. Now, for number 2, I have parentheses on one side, but I don't have parentheses on the other. So what it looks like is, it looks like I multiplied. It looks like we multiplied. We just did that. It's called distributive property. Okay, number 3, I start with 2x, I multiply by 1, I end with 2x. That is the identity property of multiplication, or multiplicative. I can't even say that word right. I should not have written that down. I apologize. But that is the identity of multiplication. All right, next. Oh, I see parentheses. I'm thinking maybe it's associative. Let's check the order of the letters. Or terms, I mean. M, N, 3, and M3. No, that they are not in the same order. So we'll go back to the beginning of our notes, right? The order switched, but we still have the same terms. They're just in a different order. So that's commutative property of addition. All right, 5, all of 5 minus k, or the quantity 5 minus k times 0 equals 0. What property do you think that is? It's the property of 0, the 0 property. Okay, they always equal 0. We multiply and we equal 0. All right, oh, I see parentheses again. I'm thinking associative. Let me see if they're in the same order. 7W3, W3, 7. They are not in the same order. But it looks like I multiplied 7 times the quantity W3, and then on the other side I did the quantity W plus 3 times 7. So the order is switched so that it's the commutative property of multiplication. All right, we're going to name the additive inverse of 16. Remember, adding the inverse is adding the opposite number. That would be negative 16. For number 8, the multiplicative inverse of 3 over 7, we simply just flip that fraction upside down and get 7 over 3. That's how easy it is. All right, guys, well, you have a worksheet that's your homework. It's single-sided. In addition to the worksheet, there are 2 or 3 more IXLs that aren't due until the 16th of March, which is next Tuesday, but you should try to get them done. They should be fairly simple. So they are A9, A1, and H1, all in Algebra 1. All right, you guys have any questions, just send me a message on Schoology. I'll be happy to help. Have an awesome day. Bye.